Hi, hello everyone. Welcome to Vision classes. The classes for IGCSE, GCSE, and AS and A level students. So this is second part of our MCQ discussion of IGCSE past year paper question. So this is October November 2021 paper. All right. So and previously we have discussed how to tackle MCQ questions. Fine. Here also we are gonna discuss how to tackle these questions and tips and tricks into it as well. So let's start here. We have a question. Photographer sees the image as shown. So this is photographer. This is image, fine. And this is X. So X, it can be anything, but here in this case, we have to identify what it is basically. So X, it might be mirror, glass block, or transparent glass prism, and then transparent semicircular glass block. So first of all, we will identify just what are the properties relating to the each and every other object. So whatever we have placed at a X. So mirror, if you place it, we will get the distance, equidistance from the mirror, fine. And then it's a virtual image, all right. Upright inverted image we will get. And it seems to me that it's a equidistance, all right. And then even upright inverted image, virtual image, we are getting it. And even we will discuss the other image, what kind of image we will. So correct answer is here A. But apart from that, in case of translucent glass block, what kind of image we will get? It's a basically blurred image we will. Generally blurred image we will get in case of translucent block. Fine. Then transparent glass prism. Now, glass prism, basically white light passes through it. Actually, you will get the colors of different wavelength. Will not get the image at exactly same, fine, that we are getting here. Then transparent semicircular glass block. It does not refract it basically in case of semicircular glass block in this case. So there is no question of getting the image that what we are getting here. So that's also not correct answer. Then next one, sun emits the infrared radiation light. The light from the sun reaches the earth in 8 minutes. Which row gives the correct information about the infrared radiation? So in wavelength, if you look at the wavelength, electromagnetic wavelength part, the infrared radiations are longer wavelength. So we have two options of longer than the wavelength of light, fine, and the longer than the wavelength of light, and the time taken for the infrared radiation to reach the earth. Here already they have answered this question. So the answer is A, isn't it? Half of the answer given in the question itself. So just keep in mind that you have to aware of what you are reading. Okay, so what you are getting from the question as well, right? So infrared radiation has a longer wavelength, and since it travel at the same speed as that of speed of light, it takes the same time to reach the earth, isn't it? Interesting. Then here the second option is much less than. No, it's not correct one. Then third one, shorter wavelength, doesn't make sense. And again shorter wavelength, much more than the 8 minute, also doesn't make sense. Point. So here trick is to remember the electronic spectrum. Fine. So what are they? Left, right, center? You have what kind of waves are there, where radio waves are placed. Even this might question before even radio waves as well. So you might not know, right? Isn't it? So you must be prepared these kind of questions. Okay. Then nextly, which row gives the typical value of speed of sound at the room temperature in the material stated? Fine. So the speed of sound in air, water, and iron. So these are the options given: 340, 1500, 5001, 340, 5100, 1500, then 5100, 1500, 340. And D option is same, 3 times 10 to the power of 8. So if you look at this, correct order is basically solid greater than liquid greater than the gaseous or air, fine. This is the sequence of order. Means more the molecular are closer, the faster the speed of sound, fine. So in this case, the air is lesser than water is lesser than iron. We have a option A is correct one. Fine. B doesn't make sense. D doesn't make sense. And C is exactly opposite. So also doesn't make sense. Fine. Then 24th one, ultrasound. Ultra means greater, right? So ultrasound means beyond the human hearing range here. So we have this ultrasound definition is above 20,000 hertz, isn't it? So here we'll read out all the options. So sound waves that are so loud that they damage the human hearing, sound waves that are too high pitched for the humans to hear, the sound waves that are too low pitched for human to hear, and sound that are too quiet for the hear. Here, these ultrasounds are more specifically high pitched, okay, and they are high pitched for human to hear. So this B is more appropriate answer than other three. Okay, low pitched doesn't, too quiet, no. Then louder doesn't make sense as well. So the more appropriate is B1. Fine. Then next one, a stationary charged particle in the field is in the field. This is stationary, okay? Which field can cause there to be the force on this particle due to its charge. Now you must know the where the gravitational field exists, magnetic and electric field exist. So gravitational field is basically force due to mass, not a charge. Fine. So force due to mass. Fine. But here they are asking the charge, force due to particle charge. Then magnetic, basically moving charge experience the force. So if charges are moving in the wire and they are in the magnetic field, they experience the force, but not a stationary one. And the stationary only experience in case of electric field. All right. So the appropriate answer is only 3, D, not 1 and 2. Getting it? Then next one, the electric current in the copper wire is due to flow of charge. So which particles are moving along the wire? Alpha particle, copper nuclei, electrons and protons. So alpha particles are associated with the basically radioactive decay here. So this one also doesn't make sense. Then nextly, copper nuclei basically contain the proton and neutron. Then it is also not electrons also basically actually they move. Why? Moving along the wire. Proton, no, they are positively charged. All right. So correct answer is the electron. Fine. Next one. The row is correct one. Next, we have to identify. So definition of current. Current is basically Q over T. So we have two options which contain the Q over T, and the conventional current second column. Conventional current always moves from the positive end to negative. All right. So positive to negative we have to identify. So first option is positive to negative. Even the formula for current is equal to Q over I also correct. So correct answer is A. Unit for charges, coulomb. Unit for time, it's a second. So just to remember, fine, these things. So this is negative to, second option is negative to positive, doesn't make sense. Then the formulas are not correct in C and D, so we can remove them automatically. All right. Then next one, the diagram shows a circuit containing two resistors of resistance 1 and 2. The voltmeter is connected across the 1 ohm resistor by connecting P to X. All right. So here the voltmeter reading is 6 volt is given. P is moved to the point Y in the circuit. What is the new reading on the voltmeter? So see, here we have a one trick. Okay. This is series circuit, right? In series, I is same, means current is same, isn't it? So voltage divides. So firstly, we can calculate the current across the whole circuit, which is current is equal to V total over R, isn't it? So V is basically just a 6 over, and it initially the P is at connecting to the X, means we can take the resistance 1 ohm, right? So which is equal to 6 ampere is the current in the circuit we will get first part, right? Then nextly R total we can calculate, which is 2 plus 1, which is 3 ohm. Fine. The V total we can calculate, which is R total, right? I is 6 times 3, which is 18 volt. And this is the voltage, isn't it? So D is the correct option. Are you getting it? And this is the easiest method we can calculate. Fine. I will explain it again because this is little bit of in-depth question. So here, when the voltmeter is connected across the 1 ohm resistor connected to X, so we can calculate the current across the circuit, which is 6 ampere, right? And this is same across the whole circuit because this is these resistors are in series. In parallel, and current is different, voltage across is same. Keep in mind, difference is very important. All right. So then we can calculate the R total. R total is basically 2 plus 1 is 3 ohm. Fine. V total is equal to I times R total, which is 318 volt. We can straight away say. Fine. Then which graph shows the current voltage characteristic for filament lamp? So first of all, filament lamp is ohmic conductor or non-ohmic conductor? It's a non-ohmic conductor. That's a first part. Fine. Then nextly, the first graph, I over V is a straight line, isn't it? It is true for the constant resistance, means it's a ohmic conductor, but filament lamp is non-ohmic conductor. Fine. Then nextly, straight line and then flat in case of B doesn't represent the continuous changes in the resistance. So this is also not correct. C is the curve that gets less steep. Fine. That's basically we can say it's not correct one because it's a more step. Fine. So voltage increases after certain time, right? And the current goes up, isn't it? So here the D is the more appropriate for the filament lamp. All right. Which means that resistance is decreasing. All right. For the filament lamp with temperature. So the graph curve gets the less steep latter part. Fine. So this is the you have to remember. Fine. So I increases with the voltage. So the D is right answer. Then 30th one we will skip it. Actually 31st one we have the 3 ohm resistors and 6 ohm resistor are connected in series with cell. Which of this correct one? All right. So here current in the cell equal to the current in resistor. That makes sense as well because current in the cell is basically current in the resistor. So then next one, the current in the cell greater. No, in the current in the resistor doesn't make sense. Potential difference across the each resistor equal to potential difference across the cell. No, potential difference are equal. This is series, right? Series case, the as I said earlier, even the current same, voltage is different. And so all these three are contradictory statements. So that's why they are not true as well. Okay. Then third one, two resistors R1 and R2 are connected in parallel. Resistance R1 is greater than R2. So here 1 upon RP is equal to 1 upon R1 plus 1 upon R2. So RP is equal to R1 R2 upon R1 plus R2. Fine. So what is the resistance of parallel combination? So this is less. Parallel combination resistance means resultant resistance. Which are the statements are correct with respect to resultant resistance we have to identify here in this case. So less than the either R1 or R2, equal to R1 and equal to R2. This depend upon the both the resistance, right? Doesn't make sense here. These two states, right? Then average of R1 and R2. No, this one also not correct. It's a less than either R1 or R2. Keep in mind this one even. And in case of series, the resultant resistance is greater than the sum of individual resistance. In case of series resistance, the resistance is greater than the each and every individual resistance. That's the statement. Fine. You have to remember. All right. So then circuit breaker and fuse are device used to protect the circuit from overloading. Which of the statement correctly describe the difference between the circuit breaker and fuse? So in case of circuit breaker and fuse, we have to remember one thing is that circuit breaker can be reset if they operate, but fuse cannot, need to be replaced. All right, so that's the difference actually. So A is most appropriate, but we will still read the B, C and D. Circuit breaker need to be replaced if they operate, but fuse to be reset now, right? Then nextly, circuit breaker can used in AC circuit, but no, this doesn't make sense. Fuse we can use in even AC, right? Circuit breaker cannot be used in AC. So the answer is 33A, fine. Then electric energy is transferred by the transmission line at a high voltage. Which statement explains the high voltage used in? So the voltage is alternating? No. Then transmission lines have a larger resistance. The transmission lines carry greater power. There is a smaller current in the transmission line for the same power. Fine. So basically here in the electrical transmission line, we use the voltage, high voltage lines, because the smaller current. Fine. That's the one reason we can say. Fine. So this is the option. Fine. So these all above three are not correct ones straight away. Fine. Then next one, 35th, we have here, which of the diagram shows the magnetic field around the straight line current carrying wire? Here the concentric circles around the wires are given. Which of the correct shape we have to represent? So this is right hand rule we have to represent, isn't it? So if you look at here, your hand, make it like this, and your fingers, basically these fingers here directed downward, right? Like this means downward, and the current arrow is thumb. Fine, your thumb actually. So it means the first one is the thumb arrow, okay, and the curly finger arrow is making downward. So the answer is here A. Here one arrow, the other arrow, these are the contradictory. Even here also it is moving up, means current moving this direction. This is also wrong. Fine. And here even current moves this direction if it is this way. All right. So this is also not correct. Fine. About the magnetic field around the straight line current carrying wire. So these type of diagrams are there. You have to understand their direction, even force, magnetic field. Fine. And the current directions are there. Left hand thumb rule, right hand thumb rule. You have to understand. You are able to apply them, okay, to identify the direction. All right. Then 36th one, coil in the DC motor is connected to the split ring commutator. So that's the main function is the reverse the current direction in the coil every half turn. That's the main function of split ring commutator. Okay, so ensure the coil continue to rotate in the same direction. They ensure the size of the current in the coil remain constant here. Then ensure the size of turning effect on the coil remain constant. No, turning effect will be different, okay, as for the current passing through the it. All right. Then ensures the turning effect on the coil changes the direction. No, this is also not correct one. So correct option here we have to ensure the coil continue to rotate in the same direction. That's the main function of commutator. Then nucleus of americium atom contain the 146 neutrons, 95 protons. It decays by emitting the alpha particle. Alpha particle is basically 4He2. Fine. How many neutrons and how many protons remain in the nucleus when this forms the americium decay? So when americium decay forms, basically we have to here 146 neutron americium, right? 95, isn't it? So here we have a 4He2. It forms the 144, isn't it? Here let's say Y I will write, and then 93 protons, isn't it? So that's what we have to check here. So the 37th here the correct one, 2 protons, neutrons. So 144 and 93. So answer, correct answer is C1. Fine, is the correct one. Then next, half life or for lead 202 is 52,500 years. The sample of lead produces 800 counts per second. How long it will take for count rate to drop 100 counts second? So we have a 800, so it becomes 100 counts second. So 800 basically divided by 2, it becomes 400, divided by 2 it becomes 200, and divided by 2 it becomes 100. Means we have a 3 half lives for the count rate to drops the 100 counts per second, right? So we have to take the total time, which is 52,500 times 3. We have to multiply in your calculator. Check what's answer. It's a 157,500 years. So the B is the right answer. All right, so I will explain it again. So here 800 counts, it becomes 100 counts, right? So 800 divided by 2 is 400, 400 divided by 2 is 200, 200 divided by 2 is just a 100. So it took 3 counts, right? So you just have to multiply by 3. It becomes, that's the time it will take. All right. Then oxygen 15 is used in the hospital. The count rate from detector placed close to the sample of oxygen 15 was recorded over the period of 15 minutes. The background count rate is 20 counts per minute. Fine. So here, yeah, count rates are given. What is the half-life of the sample oxygen? We have to calculate. Background count rate is 20 is given, right? So if we subtract from the total count rate, which is 180 minus 20, we will get 160. So 160 here, if you take it down the projection, right? And then 160. So half-life of 160 becomes 80, right? So when it becomes 80, it will be here somewhere, right? Isn't it? So approximately it will take this 1 and this is 2, right? So it will take approximately 2 minutes to complete its half life, right? So answer is here A. Getting it? I will explain it again. As you know, background count rate is 20. We have to subtract this from 180 because that's the total count rate. Fine. We will get 160. 160 divided by 2 is 80 just a, and at 80 you have to take the projection downward. All right. So, and here it's around, you will get the 2-minute time. Fine. If you calculate it. All right. Then next one, the last question. Of these 3 types of ionizing radiation, alpha, beta, gamma, why does the alpha emission cause the most ionization? Alpha particles are massive, fine. They are not as small as mass. This doesn't make sense, okay? Then next one, greatest mass. Yes, this one is correct, means B is correct. Then greatest speed, no. Gamma particles travel the greatest speed, fine. Then the greatest distance in the, means the alpha particle travel in greatest distance in the matter. No, alpha particle shortest distance due to higher mass and charge. So this is also not correct. So correct option here is B. So yeah, this is how means we have to come to the conclusion. All right. So I hope you understood all the steps and tricks, all these type of questions. So to know these kind of tips and tricks, share and subscribe to our channel as well. Thank you. Enjoy the physics.